So today, this is not a TED talk, it's a TEF talk. So the topic today is a method and it's named called Trusted Evidence Framework. And it's based also on the discussions with Barry. So first I would like to talk about why do we need trusted digital evidence. Then I would come to this OpenTox topic about trusted reproducibility, data integrity and evidence acceptance. And then I want to show you the first steps of this framework that we are working on here in Basel. So why do we need trust in new digital data? As you all know, there have been discussions around a blockchain digital health. And if you look in the past, let's say 3 weeks here in Europe, in the press was German universities were attacked by cyber attacks. There were errors in the new digital health system in Germany. So it's not tamper-proof. And on the other side, there are, especially here in Basel, with the big pharma companies, many talks about AI and new kinds of data science. So from our perspective, we see that there are two types of technologies. On one side, we have the analytic applications that you are also experts in AI, and the next trend is semantic AI. On the other side, we have below supporting new technologies like blockchain, knowledge graphs, new types of databases. But overall, we want to improve the digital health space. And here in Switzerland, in April, we will introduce a new nationwide electronic health record systems. And currently people are unsecure because there are so many press releases about cyber attacks in other countries. On the other side, as you know, the pharma companies have started this year a 4 years research project on blockchain. It's a EU project, how to apply a blockchain technology in life science. So this means there are new opportunities, but also new challenges, like how do we ensure the data integrity, the data provenance, the cybersecurity. And in the last year, we have worked together with the German Association of Pharma Companies. It's called VFA. So the pharma companies that do research, because the German government had a call to say each industry should give their opinion if a German blockchain strategy is needed. So the German government has published a blockchain strategy, and every industry has also submitted their point of view. And based on this discussion, we have published a book, and you can get a free copy. Mostly it's written in German via the German Pharma Association. And one chapter is from Barry. So other chapters are, for example, from Ein. He was in charge in Estonia to introduce the digital health system. Richard Bergström was a former director of FPR. Thomas Brenzikofer is here from Basel. Marco Como from Novartis. Michael Müller from a university hospital. Andreas Schindler from a pharma company, and Beat Wiedler, a former head of quality from Roche. And this should facilitate a little bit the discussion on this topic. How can we use maybe blockchain in this research area? And one idea that Barry and I worked on is, if we look at this process of the data processing, we have data inputs from different sites, we have new methods, we aggregate data, we predict with machine learning, and then we submit our research results. And one question is, are the results from the point of view of the domain correct? But on the other side, you have also to ask, is this whole process, does it ensure cybersecurity, data integrity, data provenance? And I think with the cyber attacks also on the German universities, researchers are becoming more and more aware that also maybe their research results could be tampered, and that would be a big loss if you have done research for the last 5 years and then your data is compromised by a cyber attack. And this situation is similar what the Estonia experienced 10 years ago. So there was a nationwide cyber attack on the e-government system of Estonia, and the Estonian people saw, if they cannot prove after a cyber attack that the data integrity is still valid, then they have a problem. And 10 years after this event, they have introduced a blockchain technology since 8 years to protect their systems. And one idea is also to use this in digital health processes. But overall, it's a topic of awareness. Are the regulators aware of the new requirements of such digital processes? And we have looked at different regulations, like the FDA. They have requirements for data integrity. From academia, there is currently this FAIR principle, very prominent, and also researchers have said this is not enough. We also have to have traceability, privacy, security. If you look at the whole GDPR discussion, or if you look at data quality in hospitals, there are a lot of requirements. But all of these requirements can be clustered together, let's say, to some checkpoints where you can audit installation or application. And this is what we have done with the idea of a trusted evidence framework. So here again, you see the principles of FAIR. Maybe you are familiar with them, especially for research universities. They are currently focusing on these 4 principles, because if they want to get a grant, they have here in Europe to give evidence that their research results will be findable, accessible, interoperable, reusable. However, there are also additional requirements that are not covered, because FAIR goes mainly about the metadata. It's not about the topic, how is the data stored and which evidence do I have to provide evidence that the data was not tampered. And there, this new framework could be from health, from help, because it could interact with the FAIR principles to enable an assessment. And in the next few minutes, I want to show you the framework. And basically, clearly, in the research area, clearly you also have digital processes. You have input data from different sources, from different researchers, maybe, and now you have to trust them. is this data set really correct? Then you apply your new research methods, maybe with advanced artificial intelligence or with other types of programs. Then you store it, and as you know, the cloud also is becoming more and more popular. So maybe you also use data storage services of a cloud provider. And then you have the output, the submission to a regulator, and then maybe in the next step, also your data results will be processed by another researcher. And to look for digital evidence in this whole process, we propose 4 layers or 4 viewpoints for checkpoints. On the upper layer, it's checkpoints from the semantic view. The next layer would be the data provenance checkpoints which are concerned to your application, and infrastructure checkpoints. So if we look at the first layer, clearly you have to provide evidence that all parties in this process use the semantic interoperable model. So these are questions about the correctness of metadata, vocabulary. Also, how do you prove that you used the right metadata and that the metadata was not tampered? On the other hand, you have also to have the evidence for the regulatory requirements. So this means you have to have a correct interpretation of the requirements. And if we look at to the US or Europe, also in the legal textbooks, there is room for interpretation. So this means we need also for the requirements a semantic model. In the next step, we have checkpoints for the evidences of data integrity, time, and the authorship. And as you maybe all know, some of maybe methods like hash values for data integrity are more than 30 years ago old, or were invented 30 years and now with the whole blockchain discussion, these ideas come again and are more advanced. However, the challenge is not only to prove the data integrity, you also have to prove the time and authorships of the data. And then you also have to provide evidence that the integrity of the whole process that you performed is not tampered. So this means in this framework, we have a list of criteria and checkpoints for each of this evaluation criteria. The next point is more concerned to the application. And there also the question comes, how do you provide evidence of the correct configuration of your application or of the code that you used? Yeah? And for example, in the military or also in the flight industry, people are concerned if they have huge software packages that contain of more than 500 different contributors. How can you ensure that there was no supply chain attack on the code, so that a malicious code was introduced into the application? So this means also you need evidence to provide evidence that shows that your application software was not tampered. In addition, you have the classical cybersecurity checkpoints, and there are in the US and in Europe different frameworks available for audits to check this. And the last layer of checkpoints is concerned to the infrastructure. So this means, how do you give evidence that the data was stored correct and was not tampered? And a very machine-oriented layer would be the evidence for cybersecurity on the machine level. So you might know that also Google tries to implement trust elements in their data centers and in their computers. So in the end, also you have to break down the cybersecurity to the physical level. So this means we have a set of evaluation points that try to simplify and aggregate the requirements for data integrity, for data provenance, and semantic interoperability. And our proposal is to work out an assessment method so that you could, in a first step, take an online assessment. These inputs would then be discussed in an on-site workshop, and from these results we would generate a report and an improvement plan, and the improvement plan could also show which new technologies like blockchain or other security methods could be used in your future research process. And to close the presentation, also Barry has published on the website a challenge, and maybe I would hand over to Barry to talk about this challenge that is planned.